Everybody's least favorite conic is always the hyperbola. Hands down, everybody hates it. The ellipse, not a big deal, kind of like a circle. Parabolas, you're used to parabolas. Circles, no problem. Hyperbolas, people lose their ever-loving minds about it. Well, let's hopefully by the end of this video you still have your ever-loving mind, but maybe you'll be a little better off. Okay, so there's a formal definition of a hyperbola. If I'm looking over here, what I can say is that I've got 2 points. And what I want to do is I want to describe all the points where if I have a point here, the difference between this length and that length is a constant. The absolute difference. By that I mean if it came out to be negative, you just take the absolute value of it. And again, so the difference between the distance here and the distance there, if you subtract those lengths, it should be a constant. Now, again, that also goes on the other end, on the other side. And so a hyperbola, that's the formal definition. So right, that's that geometric style definition where you're describing things in terms of other things and you're not using these algebraic quantities. Now, what's neat about a parabola is parabolas have this sort of X bar that runs down the middle. So there's this center point that's directly between the two foci, and then there's this sort of X bar that happens, and parabolas sort of ride the rails here. You'll also have these vertices. We didn't represent them here, but there's these vertices, and you kind of come down, you hit the vertex. You hit the vertex, and then you go back. This really should be asymptotically approaching this, more like these. I'm kind of bending away, but that's just the marker. Anyway, so the idea there is that's basically the construction of a hyperbola. It has this smoothing out behavior. It approaches these lines long term. It's not like a parabola. Parabolas don't align themselves to some sort of line, but hyperbolas do. They align themselves to these asymptotes here. And so, in that way, they're kind of neat. But again, that's that on-ramp thing, right? When you're merging on, if this is the traffic, you're merging onto it. Hyperbolas behave that way. Now, there's a standard algebraic form, and if you look at the algebraic form, it looks a lot like an ellipse. So you have something that looks a lot like an ellipse, except you have a negative here. And that can kind of mess with you, because in the case where in the ellipse, it was a plus, so the only thing we worried about was what the denominator value was, which one was bigger, and that told you whether or not you sort of had a fat or a tall ellipse. In the case of a hyperbola, it's not that. You're really looking at whether or not you're talking about something opening this way or opening that way. So you can think of it like an ellipse getting stretched until it snaps. That's kind of if you kind of take this little slider and mess with those values, you can get something to kind of do like that. And then if it's a tall one, it goes like that and kind of snaps. And you can kind of play around with that. That's pretty neat, a way to kind of get some intuition there. But anyway, the standard form, really you have to figure out which one of these has the negative. Once you've figured out which one has the negative, that tells you which the transverse axis is. And that's a fancy word. Don't worry about that. You're really just looking about matching a category. You're saying, all right, if the y version is negative, it's a horizontal one. If the x version is negative, it's vertical. And that kind of makes sense, because this would be y equals 1 plus x squared, right? So that's kind of like a hyperbola, except that it's a y squared. But it's kind of got that hyperbola style, right? Y equals some sort of x. And then this one is like x equals 1 plus y or whatever. Anyway, so you have this form, and then again, this is a squared and b squared. Now we have these asymptotes. Now we're going to get to this in a second. I want to focus on this idea of a box. So one thing that's really neat about hyperbolas is they're actually a lot easier to graph than you might think. What you're going to do is you're going to say, all right, I've got some sort of center. I've got some sort of center. And I know that I have these x bars here. So I need to find these vertices And I know that those are gonna, and we're gonna look at what those widths are. And then I can find a box here, and I can draw a box that these X bars go through, which is what we're gonna do over here. If I draw those bars that go through the center, and I go out certain distances, I draw this box, then through the corners in the center, through the corners, through that rectangle, I can draw the asymptotes. If you can get that box, you can get everything. It's easy. So the key is drawing the box. So in the box, what you do is you say, all right, I've got my center. I've got my center here. So I just take, I know what A is. I know what A is because I've got this in the form. And I just go over A, and I go back A. So I have H plus K. I add A to get H plus A. I subtract A to get H minus A. Okay, simple enough. And I have a B. So I add B, and I subtract B. Now notice this is exactly the way you do for ellipse, right? Remember when we did an ellipse, you had the minor axis, you had the major, or you had the major axis and the minor axis, and you started there, and you went over, and you went over, and you went up, and you went up. You do the same points that you do for an ellipse. Same points you do for an ellipse. But you're not drawing an ellipse. You're drawing this rectangle that goes through all these points and is centered at the center. If you draw that same thing that you drew for an ellipse with these points automatically your vertices. Automatically you have your vertices because they're these points. Then you know the heights here, so you can just draw yourself a little box that goes through all there. The asymptotes go through the corners, and you just ride the lines. You just make sure that you ride the asymptote, you come and hit the vertex and ride the asymptote, and you're done. That's it. That's all you have to do. Now we're going to walk through an example of how you would do this. If I give you this right here, the first thing you got to do is determine the transverse axis. The transverse axis is going to be dependent on which one of these has the negative. In this case, the Y version has the negative. Okay, so I know it's horizontal. That tells me it's going to open this way. Good deal. Then I need to figure out what A and B are. So figuring out what A and B are, well, I know it's this form, so this is A squared. So that tells me A is 4, not 16, it's 4 because we're dealing with A squared. And this tells me B is 3, not 9, B is 3. Alright, so my center, which is HK, is 3 and 0. Now, right, we've normally only dealt with Y plus or blah, 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 but if it's just Y squared, the center is 0. If that was X squared, that center would be 0. That center piece would be 0. So it's 3, 0. So there's your center. Okay. Because again, we're trying to get this box points. Now I've got my center. I've got H, K, A, and B. That's all I need. And this is kind of nasty to look at. Don't even look at it like that. You've got your center. Draw your center. Step over 4, because that's A. And step back 4. Okay? Now step up 3 and step down 3. That's all we're doing. We're stepping over, we're stepping back, we're stepping up, we're stepping down. And then we're going to draw our box. We're going to draw our box in center. The next step is real easy. Draw your asymptotes. Draw your asymptotes through the box. You're going to go corner, center, corner, out. Corner, center, corner, out. Right, that's drawing your X bar. And then finally ride the lines. That's it. That red, you're going to go up, you're going to hit the point, you're going to go. Now you can draw extra points if you want to, but I guarantee you do this, it's going to look a lot better than it's going to look really good. It's going to look surprisingly good for something that you just sort of eyeballed. I mean, look at this. This isn't the best hyperbola that's ever existed, but it's not bad. And I didn't work hard at this at all. So I'm telling you, if you follow these rules, you wrap your head around it, you do a few examples, drawing hyperbolas is not as difficult as most people initially think.